Thank you. Thanks to the organizers for giving me the opportunity to give this keynote and also allowing me to go a bit into the depth. So Solara is a framework we built to simplify building complex dashboards in Python. And I put an asterisk to dashboard because actually Solara is a web framework with a focus towards like data apps. But data apps is not really a word many people know. A web app is too general, and we noticed that actually many people describe what they want, even though it's not a dashboard, describe it as a dashboard. So that's why the asterisks. Shortly about me, I started as a software engineer. Out of curiosity, went into astrophysics, did my PhD and postdoc, and this is what Dolly thinks I look like during my postdoc when I was developing 2 libraries to help our group assist their work, which is VEX, an out-of-core data frame library, and something IPyVolume, which is a 3D library for visualization built on top of IPyWidgets. And because of this work, I became a freelancer in 2018 because people really wanted to build dashboards. And so I continued working on IPyWidget, became a distinguished contributor, IPyWidget maintainer, and helped co-create Voila, that allows you to go from a Jupyter notebook to a dashboard. Continued development on VEX, but basically all my clients drove me towards creating dashboards. And that now led to the company we started with Jetty, co-founded that with Mario. We now have a staff of 3 and growing. So I want to take a little bit of a step back, why we actually write dashboards, why we write them in pure Python or want to write them in pure Python, and what the problems are that we encountered when writing like more complex dashboards or web apps. I'll talk about the solutions, like in the abstract sense, but I'll give Solara examples to get a bit a more concrete feeling what the code would look like. As always, I prefer to give a live demo to get a bit of a feeling what it is like to use it in practice. After that, I can actually better describe what Solara is. I want to give some examples to show you that it's not just a hobby project that is not being used, it's really being used. And I've been blown away by all the AI, LLM work that's been going on over the last year or months or weeks, I should say. And I want to talk a little bit about how you can integrate AI in web applications and dashboards. So why do we actually do this? So for most reasons, we have some data, we want to get some insight, we want to share that knowledge or insight, or it's some kind of task that we want to automate, make more efficient. Usually in like science, like my background in astronomy, it wasn't about money, but if you are in business, it's usually about saving or earning money as a next step. And I thought, like, what's a concrete example of that? And actually, one of my first jobs was a aluminum meltery. So they basically produced aluminum. And basically, you have the raw material, you heat that up, and then the process becomes exothermic, so you don't have to heat it up again. And they logged all the data, and they really used like paper to log the data. And what we built is something to like automate that. But it was interesting to see like how did they work with this data. And they basically looked at the power usage and the temperature, and they actually overlaid those 2 graphs, hold it up to the light to see through them and compare them. But of course, the time window was limited by the arm span of the humans holding the paper. So it was not really a sophisticated method. So we automated that, made a dashboard where you can zoom in, zoom out on arbitrary timescales and pen. And they actually found out that they could save cost quite a lot and earn this project back in a short time. So just to give a concrete example. Why are we actually producing pure Python web dashboards? So actually everything's web-based now, so I don't think I want to go into that. But pure Python, because it's actually quite expensive to do backend and frontend development, to do this separately. It's technically complex. People need to know much more than just the domain expert that already know Python. And if you can stay in Python land, you can easily access all the Python libraries that are available, instead of having to access it via an API. So much faster in development and refactoring. As a team interchangeability, if the front-end person becomes sick, you can't continue developing, so it's much more easier if everything is in Python. Summary, easier, faster, cheaper. So we help companies build more complex applications or dashboards, and what are the problems that we saw? So usually it starts out as a small project. Here on the bottom left, really small, limited functionality, and no problems at all. But as the project started growing, actually a lot of unrelated problems related to more of the framework that we're using came up. And that basically made people feel like this grumpy cat. And what we wanted was something where we can actually go to these more complex applications or dashboards without feeling like this cat and feel more like this cat. And I think we succeeded with that using Solara. So what are the problems we observed? And because I'm an IPyWidget maintainer, I can explicitly mention those, but there are other frameworks that you can fill in yourself. And I talked about these problems, and that's what we call formally incidental complexity. You adopt a framework, and all of a sudden it doesn't work the way you want, and you have to work around it, and you have lots of trouble. So you want to reduce that. And you can reduce that by not spreading your state of your application in your UI. So I'm going to talk a bit about that. Imperative, like manually creating your UI, manually adding UI elements and removing them. Manually adding and removing event handlers leads to a lot of bugs and difficult to maintain such code. And it's really difficult if you have state outside and state spread among your UI elements to keep them in sync. And basically what often happens is your UI is in inconsistent state. Someone clicks a button, something doesn't update, something's not exactly right. And especially with IPyWidget, we had a trouble reusing code. That's pretty difficult actually in UIs, but I think we have a solution to that. Another thing is if the framework was too limited, and we saw that in many frameworks, we couldn't continue. It was just too limited. Didn't have these features. Can you step outside? So yeah, we felt like this for quite some projects. And I think there's a much more focus nowadays on being developer friendly. What we had with IPyWidget, like kernel restarts, that's super annoying if you want to iterate fast. No type checking. I think modern libraries should now have type checking that also allows you to iterate much faster. You get feedback if you're doing things wrong in your editor directly when typing. And testing frameworks. If you want to put something in production, you want to make sure that you can test your framework and that it doesn't break if someone makes a pull request. So how do we solve this? We actually looked at the JavaScript world. They've been building UIs for a long time, really large projects, and they've been doing it quite successful. Most of them use, or a lot of them use ReactJS, so we looked at that for inspiration. And we looked at an alternative to that and a sub-project Signals, which was really interesting to get reactivity. So the main points, I think, of solving this complexity in UI is your UI should be declarative, and I'm going to go into this now. Reactive, have some kind of encapsulation, components that you're able to use and compose. And you have to have a story for state management. In larger applications, that becomes a real problem. And hopefully feel like this cat. So what is reactive? I think most people have in their life probably used a spreadsheet or Excel. updates are always automatic. The UI always reflects the data. If I change a cell, so here I have length, width, and area, which is just the multiplication. If I change one number, everything that depends on it will recompute. So you cannot make a mistake. You don't have to change this number and then go through all the cells that you want to update. So how would that look in Python? So let's assume there's a hypothetical library called Solara that displays the first 20 rows in our data frame. And what we want, if we say hit a button, trigger an event handler, and that changes the max rows, that it automatically redraws, that we don't have to think about that. But that's not possible in Python. You cannot observe values except this person. You can Google him. On PyData channel has some awesome videos. But mere mortals cannot do this in Python. But what you can do is create like a container for a particular value. So we have like reactive values that we introduced in Solara. And there you can add a value property. And there you can actually observe when the value is being read. So here in the bottom, you see that we use it so we can automatically add event handlers. And if we write it, we can trigger those event handlers. So you don't have to think like when things should update. So declarative, tell what you want, not how to do this. And Richie Finkel already gave a good introduction there this morning about the expression system, where you basically tell polars like, I want this computation. You don't say when you want the filter to be applied. That's something that they can optimize for you. You just say, this is the result I want, and it's up to polars on how to compute it. So at home, we want to build a new kitchen, not this one. But if you want to build a kitchen, you basically want to say, I want this, and let the builder do it. You don't want to say, like, first do the ceiling, then the floor, and maybe it's like the wrong order. You don't want to worry about that. So how does that this concept, declarative, translate to a web framework or UI framework? An idea to think about it is that your UI is a function of your data. So let's make this concrete. So I introduced these reactive variables. So we have messages, which is a reactive variable. Oh, there shouldn't be a dot value here, actually. And we can add to this, and we can reset it. And so this is our data. And we just want to say, like, OK, what kind of UI do you want here? So let's build this component. If the length is 0, we want to show a warning, like, hey, there's no messages yet. And otherwise, we just want to show some information component. And this may seem trivial, but what you're doing, you're describing what you want based on the data. But actually, underneath, there's a lot of transitions that can happen automatically in Solara. So you don't have to manually create your UI. You don't have to manually update it. If the messages change, it will update. You don't have to insert new elements, and what almost nobody does, it just memory leaks. You don't have to manually delete it. That's something that we do. You just tell us what you want. So now I'm going to go a bit more technical, because I think this is a good concept to grasp. This kind of like where the power is of Solara. So we have a quite simple code here. We take the unique values of a particular column in a data frame. We create a figure, we add a bar plot, and we display it using Solara. We can optionally set a title. And you can imagine having a function that does it that you reuse for your favorite dashboard. OK, so we're going to reuse this. Now I turn this into a component by putting in this, like making it a function and giving it a decorator. And now I can reuse it. So my parent component makes 2 bar charts and some other stuff. Well, you say, well, Maarten, what are you doing? First, you're using this camel casing, why? And isn't this just a function? And it's not exactly the same. So this actually makes the function kind of lazy. So when I call it here, it won't execute it. I just say, like, I want a bar chart here. And when needed, it will execute the function. But if this reactive variable changes, this will get re-executed again. So it will call this bar chart function. Well, it actually doesn't call it. I say, I want this bar chart here, but it's the same one. The arguments didn't change. So it will not re-execute this function. So that's the difference. And I think there's also a strong difference between, I think people that have used Streamlet recognize this like re-execution, but it's more like a re-execution of the whole script, and this is on a more granular level, on a component level. But now, we're going to make it a little bit different. We have an extra argument color here, and our top-level component allows us to set a color. So we have a color picker, so someone can change the bar chart color. So this argument can change, and then we need to re-execute this. So why are we actually re-executing the whole value counts when just the color is changing? And now I should come back to why the camel casing. So the camel casing is actually because this component is it's actually more like a class than it is a function, because there's a lifetime associated to it. It doesn't have an explicit self, but kind of an implicit self. Let me show you how you can make use of this. So if we re-execute the same component instance a second time with a different color, we don't want the computation to trigger twice. And there are what are called hooks. That comes from the ReactJS API. We adopted the same API as this use memo. So what you can say, I want this function to be executed if one of these dependencies change. And now it will only re-execute if you change the column, not the color. So you see there's actually a lifetime associated to this function. So when it re-executes, it actually has memory of the previous execution. Then you say, well, I'm not using Polar, so this is too slow. I'm calling use memo, but it takes like 2 seconds to compute. My UI is like not responsive. How do I fix this? There's another like really popular hook in Solara, which is use thread. And then again in green, showing you just the code that is changed here, where I said, say the same thing, like execute this function, but now in a thread, only when these arguments change. And you want to, of course, add a progress bar and not show the result if it's not there yet. So hopefully this communicates like the idea of code reusability and encapsulation. Like someone from the outside cannot interfere. This is like a single component solving a quite complex job, actually. I want to talk a little bit about data flow, because I think this is also really important to think about like inconsistent state. So imagine we have a dictionary containing the countries and the cities in that country. I don't know what this middle city is, but I don't know where it is. So we have a reactive variable that tracks which country we selected. And we can what's called two-way bind this to a select, which usually renders as like a drop-down. And you see we pass in a reactive variable, not a value, but a reactive variable. So now it's two-way bind. If I change country using a button and an event handler, the select will change. If I change the select, also the value changes. So they're like locked together. But now I want to have a select also for the city. So what could possibly go wrong, right? Well, actually, if I select Eindhoven, I don't know where that is, in the Netherlands, and I change country to the United States, all of a sudden you see Eindhoven in the United States. And although you could possibly correct it, sometimes it's really important for applications never to be in that state, never to be in an illegal state, something where maybe some query crashes because of this combination, like Eindhoven in United States. So you want to step out of that. You want to have like one-way binding, be able to respond to a normal event handler. Then that event handler does the proper state management, which then trickles down. So you have this cycle of like an event handler modifying the state and that determining the UI. And if you use these patterns, you'll see that you introduce much less bugs and becomes more simple to manage. Okay, so our ideal web framework conquers complexity by having a story about state management, how data flows. It's reactive, similar to Excel, such that we don't have to manually think like, okay, what needs to update if my state changes? It's declarative. Tell what you want, so you don't have to like manually update the UI. Encapsulation, solving complicated problems in a component and being able to reuse those and compose them. If the framework is too limited, you want to reach for the building blocks. We have that as well. We're built on top of a library. So if something in Solara is not there, you can reach for the layer below it. And you can actually read our source code and modify it for your own personal use. They're friendly. I like hot reloading. Just save and you see the result. So today I'm not going to talk about it, but type checking and testing is also quite important. So this is our ideal framework, and people who've seen a talk of me probably recognize this slide. It has always worked, so let's see if it works now. Okay. So we run, we have a script, we run Solara, run, what's it called? No worries. It complains, no object with name, page found. So every application should start with a it's much easier now with Copilot actually. No, not yet. So because we kind of have a Jupyter background, like everything that you can display in Jupyter, you can also display in Solara. So I take this crime data set from San Francisco and display it as I could display in a Jupyter notebook using the same protocols. And what we're going to take a look at is this category. I don't like this full caps. So let's see. No. Is it this one? Yeah, okay. And I showed you in the slides this, to produce this bar chart. I put this in the code here, so it's already prepared. So we could do bar charts. Almost. I think we don't have to give a title. Okay. So every time I save it, it like re-executes. Maybe it's also useful to not touch. Yeah. Maybe we want to limit it to particular categories because we can't read this. So again, we start with first like the data. What do we want to store? Okay, thank you, Copilot. And then we probably want to filter this. So almost dot value. Someone see the problem? Sorry? This, you mean? Yeah, I mean, I could do this, but I think the error is different. I want to keep the original. I mean, perfect audience for this, right? Okay. So now we have our filter data frame. We want to use it to to control what the categories are. Let's put in a sidebar. Select. Is it correct? Unique. Probably to list. Okay, I'm going to cheat a little bit. Copilot is not working with me today. Get this out of the way. So we have values. Okay. So now if I change this, it doesn't work. Where? Because I only give it this one, so it's not bidirectional. And now I can actually change this. I also showed you this more complicated one with the threads. Is it this one? So now we can actually have a progress bar. So every time this changes, we see a progress bar doing the computation and then showing it when it's ready. Okay. Just to give a bit of a feeling what this looks like. Okay, so maybe you have some colleagues that actually prefer working in a Jupyter Notebook. Because we built this on top of the IPyWidget and Jupyter Stack, we can actually run this perfectly fine in the Jupyter Notebook. The only thing different is the sidebar. There's no really a place for it, so it's listed here, but you can run it full screen if needed. So that allows you to experiment in the Jupyter Notebook. And what's also interesting, because of these reactive variables. So what did we do? Categories. Reactive value, we can actually mutate or change the value it has from the UI or from a notebook cell, and it will trigger the computation. So also in the notebook, this is a really good way of exploring your data. Reactive variables can be read out and written from the Jupyter Notebook. And as I said, I'm going to skip that. VS Code doesn't work. Okay, so I think now we are in a better position to describe a bit what Solara is. So what you saw mostly is the UI part. So that's a pure Python web framework to build apps or dashboards. It has a React-like API, plus the reactive variables, which reduce complexity of your application. You have to think less. Declarative, you just describe, and all the transitions, they go automatically, like adding and removing elements. It's composable, so I produce this bar chart component with threading that I can easily add, put into my library of favorite components and reuse in your company over and over again. Solara has a lot of built-in components. Things like buttons, sliders, you saw some of them, matplotlib support, of course, data frame support, and it's built on top of the IPyWidget ecosystem. So you can actually drill down to the underlying libraries and customize things if you need to. But it also solves common data science challenges, like threading, as I said, the use thread hook, cross-filtering and caching are really common tasks. And the state management library we built on top of it is type-safe and gives this reactive part. Something I didn't talk much about, but I was using Jupyter Notebook, but we also have the Solara server. And that's a really efficient server using Starlet or Fast API. I'll talk a bit more about this in this slide. So to give a bit of an idea of this, how is it built, how does it fit into the whole stack? So the UI part is basically the Solara components are built using React which is a React-like library in Python. That's built on top of IPyWidgets and using the IPyVuetify material design component. That gives this more modern look and feel. All of this runs in Jupyter Notebook, Jupyter Lab, voila, but also online on Colab. But I also showed you this Solara server. So it's using Fast API for the web server and the WebSocket or Starlet. but still using the same protocol. So we reuse the protocols that the browser talks to, but normally with the Jupyter stack, we reuse those same protocols. But the main difference between like running Solara in production is like the efficiency. Like in Jupyter, every user would have their own process, while here we produce what we call virtual kernels. So are people using this? Like, what can you build? I gave you a really small view of what you can build. On the Solara website, we have some like simple examples to get you started, slightly more advanced examples, but it's always difficult to give a really complex problem, and it's really hard to digest this. So here's an example where you can upload the dataset, choose the columns, draw a selection, and just download that part. There's a project called Glue, a project started at Harvard, and they use Qt. So that was a desktop application. They want to go to the web, and we're using Solara for that. You see the connection still with astronomy here, showing a nice image of the sky, but it allows you to make really complicated linked data sets where you select something in one data set, show the selection in another plot. There's a company in Switzerland called Plano that started with a prototype in a Jupyter notebook, and that's now a real product. They use Solara Server and turning more of the code also to the Solara components. And they use this application, and mostly with the drawing on the map, to plan district heating and cooling. We're running a like mentorship program actually this week, and it was pretty nice to see this example of a live dashboard. So this is showing like these values, getting them from an exchange and updating them when the value changes. There's something that is sometimes people ask like, how can I do that? But it's like almost trivial. It's because you work on the Python side, you just ask the data, set the value, and it will be synchronized in the UI. So a lot of UIs, I think in the future, will need to be able to do something with LLMs. And with that, I'm talking beyond a ChatGPT clone. I think this is something that many people want to build. It's like a modern hello world, like, okay, I want to write my own chatbot. And actually, we're going to release these chat components hopefully tomorrow, so you can actually build those. But I think it's the more interesting things you can build. And something that really triggered us was during the OpenAI Dev Day, this Wanderlust application. This was not available, the source code, so we actually produced our own variant of that. And the idea is that you can chat with an LLM, but you can actually also let it call functions on your side. So let's, in this example, we give it two functions. A function to zoom in on the map on a particular location, and a function to put a marker at a particular location. So let's see. It's always different how it works. Where do you want to go? I want to go to Eindhoven. So then the LLM can actually say like, okay, zoom into this location, this zoom level. And you can now ask it to give you particular locations that could be interesting. It's always a surprise what it comes up with. It probably hallucinates some locations. Philips Museum, etc. Would you like... Usually it does it by itself, but sometimes it needs some convincing. I don't think it's going to do that today. Yeah. And I think this is a simple concept, maybe not so useful, but the idea of being able to talk to an LLM and being able to execute tasks, I think it's a really interesting concept. And another example that afterwards what we came up with is this glue project that I described before. You can actually also do some really interesting things without chat. So this glue program allows you to link data sets. So you need to say like this column is equal to this column. And humans need to do this. And if you're a domain expert, in this case astronomy, you recognize, oh, of course, write ascension belongs to RAJ2000, right? We all know that. And declination belongs to DEJ2000. I mean, an LLM will totally understand that. But that's something we need to do manually. And if you have 10 of these data sets, you have to do that for many, many columns and many data sets. Basically map these to each other. Perfect task for an LLM. Has all this domain knowledge. So you basically send to the chatbot, these are my columns, these are the functions to link them, do your best. And actually it will, in this case, make suggestions. You can afterwards like check what you want and then like automate these. And I think this is a really nice example of how you can use an LLM to automate some of your tasks in dashboards or web apps. So Solara is open source. We have an open source community. It's MIT licensed. We do regular updates. Hope to do a release tomorrow. It's growing fast. Also, GitHub stars are trending nicely. You can join us on Discord or GitHub for community support. Yes, spelled correctly. And something interesting, what we're doing right now is a mentorship program where people work in groups to solve particular tasks with Solara, and we help them like reach that goal. It's a really interesting way of interacting with the community. They get to learn like how Solara works, while we get to see all the rough edges that we need to polish. Doing that in combination with Pluma. I'm not going to read all of this. We are a company, so we have some commercial support as well, but I'll leave this for now. So just to summarize, so hopefully I convince you that Solara simplifies building more complex dashboards in Python. It's a modern Python web framework. It pushes the boundary of the size of apps or dashboards that you can build. And it enables like a domain expert to write larger applications in 100% Python without having to modify or without having to go to like separate front-end, back-end teams. We think this is to adopt is like low risk because we're using proven technology. Like React, the API is expressive enough in JavaScript, so why not in Python? And we're using proven technology such as IPyWidget, Jupyter, and Fast API. We have an open source community if you need help. If needed, we have professional services. And hopefully, Solara will lead to less of this and more of this. Thank you.
All right, Maarten, thank you for the fantastic talk. And I think we have about 5 minutes now for some questions. Got a dice coming at you.
I speak like this in the...
Yeah.
Okay. How do you compare Solara with Streamlet?
Yeah, I personally I don't like comparisons because I'm biased. So disclaimer, I'm biased. But it's also fair to recognize like where Streamlet's purpose is and where Solara's purpose is, and we get this question a lot. So both of them are declarative. So Streamlet is also declarative. You basically say what you want, and it will re-execute and it will update what's needed. Streamlet is very simple, like simpler than Solara, although Solara, I think also in simple cases, is quite simple. It's slightly steeper learning curve, especially if you want to do the more advanced things like working with threads and other hooks. In Streamlet, it's actually difficult. You can write front-end components, but you cannot easily write back-end components in Python. I mean, I've never seen an example of that. On Solara, it's the default. Everything you write is reusable by default. Streamlet has state in the UI. Solara, we chose not to have this in the UI, because the UI, there's not always a one-to-one mapping between those. We support bidirectional communication on everything. So you can have like events, multiple events. You could have like 10 maybe events, like selecting something, clicking on a plot. And I think that's one of the weaknesses of Streamlet, that they usually get like one output. We don't try to hide the CSS. So if you have a front-end person that can help you make something nice, we have. You can put this person to use to customize it. I think Streamlet is main purpose is smaller scripts, difficult to scale beyond like a single page. I mean, they have it, but if they talk to each other, it becomes more complex. Well, that's kind of the default. And we have a tutorial especially for people coming from Streamlet.
Okay, any other questions? Maybe one that wasn't a plant in the audience?
It wasn't planned. Expected, anticipated, yeah.
Yeah. There it is.
Oh, yeah, okay. I was already anxiously looking around where to expect it from. Yeah, so for a lot of hobby projects, I think it's fairly interesting to be able to provide visualizations to people in their browser, but then you don't want to go through the effort of running a server as well. Is that something that you can do with Solara easily, for example, with PyScript? Or do you always need a server still running?
Something went wrong here. I'll try to answer. We can execute in a browser, but not with standard PyScript or PyData. We have our own views on how that should work. I think if you follow me on Twitter, within a few months you should see something on that topic, and I should leave it to that actually. But technically possible. I could show you how it works, but not something I want to publicly say something about yet.
Okay, fair enough. Thanks.
Yeah.
Anyone?
Yeah, you can just.
Do you have a similar comparison of Solara with Dash?
Dash. We do have a tutorial for people coming from Dash.
That's great.
Yeah. The main point of that tutorial is that in Dash, although technically it's possible to create a reusable component, it probably doesn't fit on my screen. That's kind of I think Dash is more for solving a particular problem, but not something where it's easy to write something that you can reuse in multiple places. There it doesn't really shine, I would say.
Okay, thanks.
Maybe useful to take a look at the tutorial. That gives you concrete examples. Yeah.
Yes, thanks.
Okay, well, let's thank Maarten for the talk.
Thank you.